Okay, so now we're actually ready to mathematically describe 2D motion. So to solve the motion of objects in 2 dimensions, we have to use the components of their vectors in our math. So what that means is that we basically have 2 equations in 2 dimensions for each of those equations we had in 1D math. For example, that means that the velocity along the x direction is equal to dx dt, and the velocity in the y direction is equal to dy dt. And the acceleration in the x direction would be dvx dt, and the acceleration in the y direction is dvy dt. So the equations are the same, but we just have to divide them up into the individual directions. And the algebraic equations have the same thing going on. There's the position equation for the x direction, the velocity equation for the x direction, and then the y direction and velocity in the y direction equations. So you have to be careful that you use the correct components for each equation, and you'll use your knowledge of vectors to figure out how to calculate those components. You also need to define your coordinate system, which is something we did a little bit of in 1D motion already when we talked about deciding that up was positive, for example. So the kind of standard coordinate system is that up is positive y direction, and that to the right is the positive x direction. So if you don't define a coordinate system, we'll usually assume that that's what you want. You also have to place the origin somewhere, and that is often just the initial position of the object, although sometimes you need to put the origin somewhere else to answer the problem that is being asked of you. So in principle, though, you can make any choice you want. You can always say that down is positive, and you'll still get the correct result by doing that. You just have to be careful that all of your quantities that you're plugging into your equation match what you chose your coordinate system to be.